All right, let's do a second kind of problem where we figure out the exact force. Where the electric field just says, oh, this is a pre-cooked example. For every Newton you put, or sorry, Coulomb you put out there, you take it times 9 million, and you'd know what the force was. This one, we're going to actually figure out the force. And to me, that's a much more concrete sort of problem. And most of the time, I like those kinds of problems. I'm going to put more of those on the test, okay? What is the force of attraction between 10 microcoulombs, that's a millionth, and 20 microcoulombs of the opposite charge that are 2 meters apart? So let's draw that real quick. Always drawing these does help, especially when you get more than one. They're 2 meters apart. This is 10 times 10 to the what? Minus 6, because it's a million. And this is 20. That's a negative. This is a plus. 20 times 10 to the minus 6th for micro. Okay, micro is a millionth. That's the distance between those two. Okay, well, we've got a formula that figures this out. It looks a lot like this one did. So the force of the electricity between here, the force of E, has got to be 9 billion, 9 times 10 to the 9th, times a fraction, right? Of the two charges, 10 times 20, but it's 10 to the minus 6, so 10 millionths of a charge. That's positive, so I'm going to keep that little positive there. This is going to be times a negative 20 times 10 to the 6th, minus 6th. I got to keep making sure I get the minuses in there. So those are your two charges, 10 times 20 times the 10 to the minus 6 is in there. And then the distance between here squared. 2 squared meters squared. And this is a coulomb and this is a coulomb. All right. The units there are Newton meters squared per coulomb squared. So let's see what we get. Again, don't take those times 10 to this in the calculator. Just take 9 times 10 times 20. 9 times 10 is 90, times 2 is 180, plus another 0 is 1800, right? 9 times 10 is 90, times 2 is 180, plus another 0 is 1800. All right? 9 times 10, 90, 20 is 1800. And so now I'm going to get what, I got to do the exponents. 10 to the 9th, 10 to the minus 6, and 10 to the minus 6. So it's 9 minus 6, which is plus 3, and 3 minus 6 is now 10 to the minus 3. That's the top of the fraction. I'm going to divide by the bottom of the fraction. Take 1800 divided by 2. Okay, that's going to give me the next step, which is just basically 900 times 10 to the, and that should be minus, my apologies, let me write this in a little better down here. Okay, so that's 900 milli forces in newtons. I can look to see that because I've got a newton here. Coulombs takes those 2 coulombs out of the top. This is coulomb squared. That takes 1 of them. That takes 2 of them. The meter squared here takes those 2 meter squareds out. So what's left is newtons. Now 900 millinewtons, or if I just take that 10 to the 3 and I say I'm going to go from millinewtons, or I'm going to move this decimal over 3. I can take that times 10 to the out. So I can say this is the force, or it's 0.900 newtons. Almost 1 newton. Okay? These are super small. These are millionths of a charge. And that's a millionth of a charge. And they have almost a single newton. That's the weight of 10 grams of mass. So that's pretty substantial for super small amounts. But that's more likely what we'll deal with millionths of a coulomb. Good.